This animation illustrates the dynamics of the McLean AirDrive submersible pump in an off-the-grid application. Once a water well has been drilled and the well casing has been installed, the McLean pump system can be put into place. This example has a single-stage McLean pump positioned at the bottom of a water well that is 700 feet deep. Additional stages of lift can be added to the McLean pump for each 700 feet of additional well depth. The pump is easily installed with an air supply line, an air exhaust line, and a PVC water pipe for water transmission from the McLean pump to the surface. Next, a windmill, or wind turbine, is installed in the vicinity of the well where there is the most wind. It can be at a considerable distance from the well site. The animation shows a multi-bladed, high-torque windmill on a steel frame tower. This is equipped with an air compressor. As the wind turns the mill, air is compressed. Compressed air is pneumatic energy. The animation shows a tank in the windmill tower. This tank stores the compressed air to be used when the wind is not turning the mill. Compressed air from the windmill, or the pressure tank, is then sent to the McLean pump in the well, putting it into motion. This is a positive displacement pump, bringing water to the surface on the upstroke and the downstroke, a quality unique to the McLean pump. The carbon footprint here is nearly zero, and at this point the McLean pump can provide water to people, livestock, and agriculture in remote locations without electricity or fossil fuels. Harnessing the wind provides clean, green, sustainable energy. At this point in our animation, the water is pumped from the well into a water storage tank. The pneumatic energy from the pump air exhaust line is also harnessed. Here, it is sent to an air pressure tank and then on to power two other vital destinations. The exhaust air in this animation illustration powers a booster pump, moving water from the water storage tank into one or several homes. As illustrated here, the second air line from exhaust air into the pressure tank operates an aquaponic sustainable food production system. In this animated illustration, the air powers a large fish tank pump. The fish are raised in the tank. Effluents accumulate in the water and are regularly pumped by air into the vegetable beds to water and fertilize. The byproducts from the aquaculture are filtered out by the plants as vital nutrients, after which the cleansed water is recirculated back to the fish by the air pressure tank. Aquaponics also has an almost zero carbon footprint. Aquaponics uses 10% of the water a normal farm uses and produces 44% more crops in a shorter period of time. Aquaponics have relied on electricity since its popular onset in the 1970s. Power outages have caused the biggest failure of these systems, causing the fish and plants to die. In our scenario, this is an off-the-grid, successful, self-sustaining, self-cleaning, symbiotic environment made possible by the McLean AirDrive submersible pump.
Lastly, the pond depicted here is an extension to the aquaponic environment. It measures 10 feet by 20 feet and is 12 inches deep. The McLean pump sends surplus air through the lines, exhausting it into the pond, thus aerating it, increasing its oxygen content. This oxygen-enriched water provides the perfect environment in which to grow duckweed, and provides oxygen for the mosquito fish in the pond, which feed on mosquito larvae. The duckweed grown in the pond provides excellent nutrition and sustenance for the fish in the aquaponic tank. Duckweed contains more beta-carotene in its makeup than any other terrestrial plant. It contains more protein than a comparable ration of soybeans. The plant itself doubles in volume every 48 hours, and a pond this size can provide enough duckweed to feed 300 fish.